Good afternoon, friends, and welcome back to another virtual MOSI. My name is Ian Reed, and this week is Physics Week. All about Einstein, Newton, all those great guys who gave us a lot of headaches in high school and college. But this is all about physics, and these are fun things you can do at your house. So for today's virtual MOSI, what we're going to do is egg drop. And so we're going to begin here in our wonderful STEAM lab, and then we're going to head out to our bridge to conduct our egg drop of two vehicles that I've kind of put together. All right, so as I said, today's challenge is to construct a vehicle that allows you to drop an egg from a height of approximately 22 feet. So we're going to go up to the bridge and drop both vehicles that I've constructed and see how well our eggs will do. But first, the science. Right? What is gravity? Now, according to the Oxford English Dictionary, gravity is the force that attracts a body toward the center of the earth or toward any other physical body having mass. So for our egg drop, we're concerned with the first part, toward the center of the earth. Now, who thought of this concept? Has gravity been around? How long has this concept been around? Or who developed this? Great question. He did, Sir Isaac Newton. Great physicist, great scientist. So, this is what happened. After he, Sir Isaac Newton, saw this fall from a tree, he wondered, why did it fall to the earth? And why did it just come down? Why didn't it just bounce and just go right back up? And so he began to develop this, and he started to think about this. And so he comes up with gravity. So he wondered, he pondered to himself, what caused it to fall? Why didn't it hit the ground? Gravity. He comes up with it, and he starts to think. So he pondered, and he pondered it so much so that he needed certain type of math to help him with his ponderings. So he comes up with calculus. So for all you kids out there that want to study chemistry, engineering, physics, other applied sciences, lean in, because this is what you're going to have to do. And this is just elementary stuff. All right? So he comes up with calculus because when the apple fell, what he was thinking about was not just as it hit the ground, but where was it here versus here versus here versus here versus here versus here versus here. And that's where we come up with this thing called an integral. You'll learn about that later. He also, with this, develops 3 laws of motion. These 3 laws are very important to developing overall physics and physics concepts. So, Newton's first law, objects in motion tend to stay in motion, objects at rest tend to stay at rest unless acted upon by an unbalanced force. Second law, force equals mass times acceleration, F equals m times a, or inertia. Third law, for every action there is an equal and opposite reaction. And so because of his ponderings and him thinking about these things, he developed these different ideas for physics. Now, here's where a lot of people kind of get a little bit in trouble. So I'm going to help you out. All right. So on this planet, all objects fall at the same rate of speed. All right. A lot of people think, well, doesn't everything fall at the same time? No, it falls at the same rate of speed. Okay, which is metric minus 9.8 meters per second. For our English or customary units, minus 32 feet per second. Both of these are squared. All right. Now, just to let you know, I'm going to go to what I call the big kid school across the street, University of South Florida. We use metric and science. Just saying. All right. So it's minus 9.8 meters per second squared. So everything falls at the same rate of speed. Okay. Now, speaking of that, let's look at this. All right. Because when we talk about speed and velocity, a couple of different things. So these are 2 very important quantities. And if you look, there is a difference. So velocity, notice in front of it, that stands for delta, that means change. All right, so the formula for velocity is the change of distance divided by the time. And it's distance final minus initial, that changes. And we call velocity a vector unit. It means it has size and direction. If you've ever been on a plane, this is what pilots use. They use vector quantities to go where they need to go. So velocity is a vector versus speed, which is just distance over time. It's what we call a scalar, so it just has size. All right. So velocity, very, very important. So it's size and direction. All right. I'll leave it like extra. Now, what do we need for today's activity? Everything. So with this activity with the egg drop, whatever you have in your house, you can use. So if we get a lot of Amazon stuff, and you have bubble wrap, you have some insulation. Don't take it from your air conditioning unit. It needs to stay there. But just have any extra lying around. There you go. Boston Market bag. Love the Boston Market tape. Scissors. Bowls from carryout. Whatever you have. Most important, eggs or the egg drop in order to drop these things. I have paper towels. Walmart bag, and so you can use these things and you can test and build your own type of vehicle and test it out to see how well you do. Now you don't have to go up to something that's 22 feet. With the help of your parents, dad, mom, if you have like a tall ladder, you can drop it off from there as well with their assistance. Don't try to do that yourself. But this is great because this is how, believe it or not, this is how NASA tests a lot of different things. They start out with prototypes and models, they test it, and wind chambers, different things of that nature, and then they write down the results. And then we build other prototypes and models and take it through simulations. So believe it or not, this is how a lot of the pros and things you hear about, this is how they started. Just by an idea, taking, pondering a thought, and then just working with that thought and developing that thought. So what we're going to do right now is we're going to take both. So I've built two. I've built one vehicle that's kind of like it's an airbag. Built another egg drop vehicle that has a parachute on it. Okay, and we're going to take a look at it both, and we're going to see how well they work. Okay, so Mr. Rogers style, come along with me, and we're going to go ahead and head out to the bridge, and we're going to test. So what we're going to do is once we get out to the bridge, we're going to climb up to the top of the bridge, and we're going to release one, and then we're going to release the other. And so we want to see which works better. Will it be the parachute that'll be able to kind of slow things down, give it a nice landing, or will it be the airbag, which once it makes that impact, it'll be able to kind of bounce around. So that's what we want to do, friends. And so what physics is the study of matter in motion, how things move around. And so that's why Newton was so very, very important in this development, because he thought of different things moving around, objects that are in motion, but he wasn't the only one. You'll learn about others as well. You heard of Einstein, he's more on the modern physics side, and then you get to something called quantum mechanics. And so it's just you just keep developing, keep thinking, moving on and on. You have to think that without physics, you watching me right now with your monitor or even watching television at home would be hard without something that was developed by J.J. Thomson, the discoverer of the electron, his electron gun or cathode tube, which is what allowed us to see television and things of that nature. So physics, very, very, very important. All right? And it's not just dropping things. The light, when we go outside, studying light, how light travels and waves. You probably heard a lot about UV light, different things of that nature. Those are also things that we study in physics. All right, so, and space as well. So you have a lot of physicists that study what happens in space, that have helped us to get to the moon and back, and hopefully you guys will be the generation that get to Mars and get to explore all kinds of wonderful stuff. All of that is physics related. Even the, if you like water guns, Dr. Lonnie Smith, physicist, he actually developed a water gun from PVC pipe, made a prototype. You guys know it as the super soaker. So as a physicist, you can do all kinds of wonderful things. So we're going to head on out. You can kind of see it from here. We're going to go to the top of the bridge. Once we drop both, we're going to open them to see as well. Whether it's physics or chemistry or biology, experimenting, doing multiple trials, things of that nature. What you have created, that's innovation. That's what engineers do. So these things are very, very, very important. Also sound. That's what also we study in physics. How sound travels, waves, things of that nature as well. Head up. And we're going to test both of our vehicles out just to see how well each of them does. This is something else you have to do. Problem solve. I didn't think it was going to be this windy, but we're going to see if both designs hold up. So we're going to start off with our parachute first. Ready down there? All right. Go. And then 3, 2, 1. Ooh. Kind of hard there. All right. So that's Brian. He is our science recovery person. He's going to take a look and see what happened with our egg. All right, thumbs up. The egg survived. You're probably wondering, well, why an egg? Well, because it is rather fragile and you want to be able to protect it. So we usually say that the egg is either a person or supplies, right? So if you were to drop this supplies off to persons living on Mars, you wouldn't want it to break or to crack, and so this is why they use these designs. Or even if someone was coming in to land on Mars, you want to make sure that your vehicle would be safe enough for them to land and get out safe. All right, so we're going to drop our next one. This is more like our airbag type. All right, let's see if you notice anything different. All right, here we go. Ready? 3, 2, 1. Wow.
Much gentler landing.
All right, much gentler. There you go. Now, so if you remember what I said was that everything falls at the same rate of speed. You probably noticed that that probably fell not as fast because you have to think about the wind as well. So while everything falls at the same rate, the reason why things that are heavier will fall faster. So if you got a bowling ball versus a feather, even though each is falling at the same rate of speed, you have to take in the wind, for example, as we're seeing right now, into consideration. So it's still falling, but the wind going around the feather, because it's so light, will cause it to probably dance around a lot. 2! That's a great batting average. 2 for 2. Batting 1,000. And so, you want to take that into consideration. So you saw a little bit of innovation. You had the parachute, and you have the airbag concept, which both actually have been used in order to land probes on the Martian surface. Parachute one time, the second time, or other times they've used like an airbag type design so that the rover can go out and explore the Martian surface there. All right, 2 for 2. And we can quickly hold that, Brian, if you don't mind. Because we want the people to see that we did not try to know them or anything like that. It's okay, it's fine. All right, and then Brian has the other one.
Trying to not break the egg after it's been retrieved.
Aha! Ta-da! So we're not kidding you there. We didn't have separate ones, so you see that they survived. So you can try this at home and maybe don't use as much stuff as I use. So maybe you don't have the Amazon airbags or the insulation. Use what you have around your home. Try it with toilet paper, try it with more paper towel, drop it off something safely with an adult there and see how well you do. All right, so thank you all for tuning in for another virtual MOSI program with our egg drop. Again, this week is all about physics, and so tune in tomorrow for tomorrow's activity. It's been great seeing you, and hopefully we'll see each other again. And remember always to keep discovering. Thanks, guys.